Today's lesson deals with solving problems in writing and solving proportions. So first off, we got to go through this vocab to understand what's going on. The first part of the vocab wants us to deal with ratios. A ratio from A to B can be written in a number of ways. A common way you might have seen is A colon B. It can be written in another way too. Did anybody find the other way? A over B. So you could also say A over B, as in a fraction. Those are two ways of writing a proportion. Obviously, you could also have written it in words, A to B. A lot of people get these ratios confused with proportions. What's an example of a proportion? Well, I'll go ahead and start you off. A fraction equals another fraction. What are some examples of some variables we could throw in there? 1/2 is equal to 2/4. That would work. Let's use some variables though. So like A over B equals C over D. So those are variables. You substitute in numbers and it's something that you're used to seeing. The key thing you have to remember about a proportion, it's a fraction equal to another fraction. Every single time. That's what a proportion is going to be set up as. And does anybody remember how to solve a proportion? Yeah, write that note out to the side too. We cross multiply. Can we cross multiply on a ratio? Nope. What can we do with a ratio? The only thing we can do is simplify. The only thing you can do with a ratio is simplify. So that means like if it was 2/4, you could simplify that to 1/2. Now it does look like a proportion, but this is how you'd show that it simplifies to 1/2. We didn't really solve anything. You can't really solve a ratio. You can only simplify a ratio. You can solve proportions by cross multiplication. I'm not going to focus too much on means and extremes. Basically, all you need to know is this. Whenever you are looking at that proportion, you focus on the diagonals. So one diagonal is considered your means, and the other one is considered your extremes. Did anybody figure out which is which? Means are what? B and C. So those are your means, and these are your extremes. Pretty simple. Geometric mean is the next one up, and this is one of the most commonly missed problems on the test. Typically, you'll use a geometric mean in this case. A over x equals x over b, where a and b are numbers, x's are variables. Let me show you an example real quick. What if we had 3 over x equals x over 12? Can we solve this? Yes. How do you solve a proportion? You cross multiply. So quickly, we're going to do x times x is what? It is not 2x. X squared. You do the other cross. 3 times 12 is 36. Can you solve that? Yeah, how do you get rid of squaring? We square root each side. So they cancel out. I'm just left with x. And what's the square root of 36? 6. That's how you solve a geometric mean problem. Here's how the question will be stated. It will say, find the geometric mean between 3 and 12. It won't set it up like this for you. It will not set up this problem for you. You'll have to know that, oh, a geometric mean means set it up in a proportion where the two numbers are on one diagonal and where x's are on the other diagonal. Example 1 goes through some simple stuff. You've done this in Algebra 1. You've done it probably in chemistry as well, some of your sciences. and it's evaluating some ratios and trying to simplify those ratios. Let's start off with part A. It's the simpler one. It says simplify the ratio 76 centimeters to 8 centimeters. So we ought to start off in writing these over here. 76 centimeters will go on top because it's written first, over 8 centimeters. The first thing that I want you to be aware of is that they have the same units. When they have the same units, your life is easy because you can go ahead and cross them out. They cancel each other. That's good. When they're directly above each other, they will cancel. So we're left with 76 over 8, and you should be able to simplify that. 76 over 8. How does that simplify? So the key thing, when trying to do this with mental math, you got to think of the biggest number that divides into both. That biggest number is 4 in this case. So we're going to divide the top and bottom numbers by 4. 8 divided by 4 is simple. 76 divided by 4. What's that one? 19. And can that simplify any more? No. I don't need to write my units because I've already realized that they cancel out. So this is my final answer. It could be written in fraction form or in this ratio form. Either one is fine. The next one's a little bit more challenging because if you notice up here, they don't have the same units. We have to deal with those units. So we're going to use some of their work down here. They say 4 feet and 24 inches. Well, what we should realize is that feet and inches are related to each other. 1 foot is how many inches? 12 inches, and you should know that. What we're going to do is we're going to create a conversion factor. So circle that word. What we're going to do is we're going to multiply by a conversion factor. Now here's the challenge. You have to figure out, does the feet go on top or bottom? What you should remember back here is they can only cancel out when you have something that's the same in top and bottom. So if I want the feet to cancel, feet are on top, where should feet be over here, top or bottom? Bottom, so they'll cancel. I have it now in top. It can cancel with the one on the bottom. That's all good. When we're multiplying, we can do this. So the other term is in inches. And inches will go in top. That way it cancels with the inches on the bottom. This is a conversion factor. It cancels out our units. Now, once again, we are multiplying by a conversion factor. The key thing on the conversion factor is making sure your units cancel top and bottom, top and bottom. The next thing, when you are multiplying fractions, how do you do that? We do not cross multiply unless there's an equals in between. You multiply straight across. Write these arrows. We multiply straight across. Multiply straight across. Please write that down. Multiply straight across. So this is pretty straightforward. What's 24 times 1? 24. And then what's 4 times 12? 48. And that simplifies again. We have 24 and 48. Those numbers are very closely related to each other. What's it going to simplify to? Top number is bigger, so it's not 1/2. It's got to be 2 over 1, and that would be your final answer. The key things to remember here is we are going to simplify a ratio, and when we simplify ratios, we're going to keep it in ratio form at the end. So in the end, it's still going to look like a ratio. It's still going to be 2 over 1. You start with a ratio, you end with a ratio. Do we need units at the end? No, because all of our units canceled, and that's what we want. When we're simplifying these, and this process is called dimensional analysis. It's good in all science and math classes. You need to be able to do these. This is obviously one of the easier types. You could have probably done it on your own without dimensional analysis because you know feet and inches really well. But some of the harder ones with kilograms, grams, and then it'll sometimes make it a little harder from there. So it'll go from feet to inches to yards to miles. So you need a bunch of conversion factors, and that's where dimensional analysis is really important. So this is a good process. Final answer, no units, leave it in fractional or ratio form, one of these two forms. Example 2 is way different from what we've been doing. So this is different. So change your mindset, start new. It says painting. You're painting barn doors. You know that the perimeter of the door is 64 feet and that the ratio of the length to the height is 3 to 5. Find the area of the doors. There's a lot of stuff to be able to do in this problem. First off, let's note the important stuff. The perimeter is how big? 64. So out to the side, I'm going to say perimeter is 64 feet. All right, barn doors are typically rectangular. So I'm going to draw a barn door so I can visualize it. Remember, perimeter is all the way around the edge. So we're counting all the way around, adding up all those pieces. The other thing you need is you need to remember what is the formula for perimeter on a rectangle. Well, this is width, length, length. We're starting with perimeter first. We've got to remember how is perimeter created, and then we'll go to area from there. So perimeter, if you aren't sure, it's perimeter equals how many W's do we have? 2 W's plus 2 L's. There's the perimeter form. So as you can see, I'm right down through here. That's my perimeter formula. The next thing we need to realize is we don't know our length and we don't know our width. All we know is that the length is right here. It's some number times 3. Some number times 3. The height, or the length is what we put. We kind of use different words. We use width and height. They use length and height. The height is 5 times that same number. So 3 of some number and 5 of some number. That's what we're going to use for our variables. So we're going to take those variables that we just found and we're going to plug them in. Since we don't have true values, we're going to plug them in for these W's and L's. So also, we're going to remember that the perimeter is 64. So we're going to use that, definitely. Now, we don't actually know our width, but we know it's a multiple of 3. So 3 times something. We don't know our other dimension. All we know is that it's 5 times something. Now we have some simple algebra to solve. What's 2 times 3x? 6x. And what's 2 times 5? And I should have wrote x there. 2 times 5x is 10x. It's getting more and more familiar. 6x's plus 10x's is 16x's. And how do you get x alone? Divide by 16. What do you get from there? 4. Now, anywhere I see an x, I'm going to plug in a 4. So I'm going to take them back up here, and I can determine that 3 times 4 is 12, and 5 times 4 is 20. These are the actual dimensions of that barn door. Our barn door is actually 12 by 20. And you can go ahead and write them in all those spots now. 20 plus 20 is 40, plus another 24, yep, 64. It added up correctly, and these units are feet. So make sure to put your units on your answer. The question says, find the area of the door. That's the last part. How do you find area of a rectangle? Base times height, or length times width. So those are our two numbers, 12 and 20. So area equals, we'll say length times width. The area is 12 times 20. And 12 times 20 is 240, and your units are feet squared. How many square units? 240 square units. Try these checkpoints now. Checkpoints 1 through 3. All right, on checkpoint number 1, it says convert or simplify 4 meters to 18 meters. I'll come out to the side. 4 meters to 18 meters. First thing you need to realize is, do they have the same units? Yes, they cancel then. So you got to show that your units cancel. Make sure you have that on your work. So we're now 4 over 18. Those are both even, so I can divide them by 2. I'm going to divide them both by 2 mentally. I don't need a calculator for this. 4 divided by 2 is 2, and 18 divided by 2 is 9. Does that simplify any more? There's my final answer, 2 to 9. No units at the end because they canceled out throughout the process. The next problem over here has 33 yards to 9 feet, so I'll work on that one out to the side. 33 yards goes on top to 9 feet. First thing, do they have the same units? No, that means I need to multiply by a conversion factor. I got to think about my conversion to feet and yards. Do you all know that conversion? 1 foot, 3 yards. So let's think, where does the feet need to go? Does the 1 yard equals 3 feet. So where does the yards need to go? On the bottom. And we put it on the bottom so that they will cancel. Top cancels with bottom. The 3 feet will go on top. That way the units on top cancel with the units on bottom. Now, how do you simplify multiplying fractions? Straight across. And until you remember that, you need to keep drawing those arrows. Remember, we multiply straight across. 33 times 3 is 99. 9 times 1 is 9. 99 divided by 9 is 11 over 1. Final answer. No units on it at the end. All right, the last one is that perimeter problem. If you don't remember, perimeter formula is P equals 2W plus 2L. So we're going to take these numbers and plug in. There's 21. This is 5 times some number, and then 2 times some number. I'm going to take those and plug them in for my W and L. 2 times 5x, 2 times 2x. So that's 10x and 4x. So that's 14x. Divide by 14 and you get x is 1.5. You have to understand, what do you do with that x? You can't just stop there. We have to take that number and plug it in. So we got to figure out, what does it mean when I plug them in up here? So 5 times 1.5 is what? So we get 7.5. And then 2 times 1.5 is 3. Those are my 2 answers, but I got to make them make sense in this problem. First thing I need to do, 7.5, well, these should be in feet. But what's a half foot? Well, that's 6 inches. So that's 7 feet, 6 inches by 3 feet. So find the length and width of the table. There is your length and width. It's 7 foot 6 inches by 3 feet. That would be a solid answer. This next problem is also a little bit different. They say the measure of the angles in the triangle are an extended ratio. An extended ratio is when they use more than 2 numbers for a ratio. They actually use 3 numbers separated by 2 colons in this case. Find the measures of the angles. The key thing you have to remember is this right here. Whenever you're dealing with interior angles of a triangle, you have how many angles? You have 1, 2, 3 angles, and they always add up to 180. These numbers right here are my x terms, kind of like we did on the rectangles. These are our x terms. 2 times some number, 3 times some number, 4 times that same number. We got to figure out what that number is. So it's 2x's plus 3x's plus 4x's. That's what we're going to simplify. 2 plus 3 is 5, plus 4 more is 9. 9x's equals 180. Divide by 9, and you get x is 20. What do we do with our x value now? Plug it back in. So I'm going to take it and I'm going to plug it in these situations. So 2 times 20 is 40 degrees. 3 times 20 is 60 degrees. And 4 times 20 is 80 degrees. Those are the 3 angle measurements. And you can make sense out of them. The 2x one, which is right here, is 40. Does that look like a 40-degree angle? To me, it does. The 3x one is 60 degrees. And the 4x one is 80 degrees. Yeah, just a little less than 90. Those make sense. When you apply it back to the picture, the problem, it makes sense. So a good way to write your final answer would have just been 40 degrees, comma, 60 degrees, comma, 80 degrees. That would be a good way to write your answer. Definitely I'd want to see this work, though, on the problem. Go down now and try out this checkpoint. See what you can do on this checkpoint. It's the same process as that example. All right, this one's really quick. So remember, these are our x terms. So 1x, 4x, and 5x. And they're always going to add up to what number for inside angles? 180. So there's 9, that's 10 x's equals 180. X is 18. Take 18 and plug it back in. 1 times 18 is just 18 degrees. 4 times 18, what's that one? 72. And then 5 times 18, what's that one? 90. Those are your 3 angle measurements. On example 4, we're doing good old proportions. These should be very simple. These are straight out of Algebra 1, maybe even a little pre-algebra on this first one. Whenever you solve proportions, you always cross-multiply. And they call it the cross products property. Same thing. Cross-multiply is all we need to do. So we're going to do 3 times 16 real quick. 3 times 16, and write it down. The other one is 4 times x, and we'll write it down. Later on, you probably don't need to write this step. 3 times 16 is 48, I think. Divide by 4, you get 12. That one is really quick. Part B is the most commonly missed one that I've seen. On this one, you have to realize that they're not all simple terms. I see 3 simple terms and one that's a little more complex. What's the one that's a little more complex? The x plus 1. So what you need to do, when you find that complex term or that more challenging one, you put parentheses around it. And the reason why we do that is because it's a group of terms. So we use grouping symbols. We use those parentheses. So now when we do 3 times x, we can write that. And you definitely need to write this next part. 2 times this group. 2 times this group. And write the whole group written in parentheses. The reason we do that is because we're supposed to remember when we see a number outside parentheses, what do? We're going to distribute that inside. So 2 times x is 2x. 2 times 1 is normalo 2. Now, how do we get these x's together? 1's on the other side, so how do we move it? Subtract 2x, and I get 1x. And I'm just left with the 2 on the other side. There's our final answer. Now we're going to do this example 6. It deals with geometric mean. What you should remember is, what does geometric mean look like? Well, it looks like a proportion. It has x's on one diagonal and numbers on the other diagonal. So it says find the geometric mean of 16 and 48. Where do I plug in 16 and 48? For the numbers. So here's 16, and here's 48. Now I could have put the x's on this one and numbers on this one. It really doesn't matter, but we'll go from here. This is the normal way you'll see it. What is x times x? X squared. Now this other one's going to be a bigger number. 16 times 48. 768. Now what do we remember to do about that square value? Square root it on each side. That way they cancel on the left. And square root of 68 is approximately 27.7. A little bit better answer would have a few more decimal places, and I think it's 713. Now I will take that for the time being. In the near future, we're going to be simplifying these radicals. So I'll take this for now. If it doesn't tell you how to round, you round to 3 places. Go down and try 5 and 6 now. Try checkpoints 5 and 6. All right, I'm going to go kind of quick on 5 and 6. Cross multiplying. 8 times 5. I can already do that mentally. It's 40. Y times 2 is just 2y. Divide by 2 on each side. 40 divided by 2 is 20. The other one's a little more complex. We have a group of terms, so we use grouping symbols. I'll do this one first. 2x times 3, and I'll write it out this time because I want to show this other step. 9 times that group. 9 followed by parentheses x minus 3. 2x times 3 is 6x's. 9 times x, and then 9 times negative 3. So we have 9x minus 27x. Now how do you solve from here? What do we need to move? Typically we move the smaller term because it's easier to move. But if we move it, then we're left with nothing. So we're actually going to move the big term in this case. They cancel on the right. On the left, I'm left with negative 3x equals negative 27. I have 2 negatives. That negative is going to disappear when I divide by this negative 3. When you divide by negative 3, what do you get? Positive 9 as your final answer. That's a good problem to be able to do. The last one I want you to try is number 8. Find the geometric mean between these two numbers. Go ahead and try that one real quick. All right, so this last one. Here's the quick answer. Please pay attention. It's x over, sorry, we did the x on bottom. So 14 over x equals x over 16. X times x is x squared. 14 times 16 is what? 224. Take the square root of each side. They cancel. The square root of 224 is about 14.977. I assume that's rounded properly. If it is, we're good to go. All right, so I've just heard that this is a 6 instead, so 967. There's your final answer.